Good afternoon, folks. This is for Algebra 1, Chapter 9, Lesson 4, Solving Quadratic Equations. When they mean solving a quadratic equation, they basically are just talking about finding the x-intercepts. It's when y equals 0 when you have both an x and y in your quadratic equations. So far, you guys have been used to just graphing them. Basically, what we're doing now is mathematically finding the x-intercepts. So when y is 0, it's now called a quadratic equation. The other thing is, though, is sometimes you won't even have the y in there to set to 0. You will in the next lesson. But basically, we're just figuring out what x is when y is 0, or when there is no y. All right? So, this is in standard form when you have ax squared plus bx plus c equals 0, though in this lesson, you won't have any bx's. Okay? You will in the next one, but not in this one. Okay, and we call it the standard form of a quadratic equation, and the quadratic equations for this course will have 2 or 3 possible outcomes, either 2, 1, or no real solutions. And when we're talking about solutions, it's basically what the x-intercept is, and that's basically where the parabola hits the x-axis. So, if you have 2 solutions, that means that there's 2 points where the parabola hits the y-axis. Alright, 2 points of the parabola going through or hitting the x-axis. One solution is 1 point where the parabola hits the x-axis, and this is normally the vertex. So the vertex is the 1 point, because normally the parabola has the 2 sides that come up, either up or down. Well, if there's only one solution, 1 point that hits the x-axis, that's normally the vertex. And then no solution, basically no points of the parabola hit the x-axis, and the vertex has a maximum, the vertex maximum is below the x-axis, or the vertex minimum is above the x-axis. Okay, so there we go. Those are the 3 possible outcomes you can have when solving for the x-axis. Now you can go through obviously and graph all of these and visualize them, and for some of you that might be easier, but you definitely need to know how to do it mathematically, especially considering it uses a lot of the last lesson, 9.3, and solving square roots. Because we need to be able to undo squares, especially considering quadratic equations naturally have squares, because without the square they are not quadratic, they're not a parabola. Okay, if you have a cube, you've got something more complicated than the parabola. If you don't have any squares or any to the second powers, then it's just a straight line, okay, which basically means no parabola. Alright, so solution of quadratic equations and the related x-intercepts are then often called the root of the equation, or zeros of the function, because basically we want to figure out when y is 0, what x is. And the thing is, with a parabola, it is possible to have 2 x-intercepts, so basically 2 points where y is 0. So let's go ahead and figure those out. But first, let's go ahead and take a quick look at some of these graphs. For this particular lesson, we're not going to have any bx's. It's just going to be ax plus or minus c equals 0 or equals something else. And so here are the graphs. We have a 2-point example, basically where the parabola hits twice on the x-axis, twice where y equals 0, right there, once where y equals 0, where there's only one solution, and then where it doesn't hit 0 at all. It doesn't hit the y-axis at all, okay, basically where there is no y equals 0. All right, there's no x-intercept. So those are the 3 possible outcomes and what they can look like. Now we're going to figure out how to do them mathematically. So here are some example problems. And just remember, some answers can have no solution, 1 solution, or 2 solutions. If they have 2 solutions, that means that the square root of a number, or the square of a number, could be plus or negative, positive or negative. No solution basically means that it is not possible to take the square of a number and get a negative number, which I'll show you in just a second. And then, so that was, okay, let me start over. No solution means basically if you get something kind of like this. If you get g squared equals negative 9. It's not possible to get that because there's no 2 numbers that when you multiply them together, if you replace g with a number to square it and then get a negative outcome. This is a no solution situation, All right, whereas one solution is basically something that could look like this: x squared equals 0. Well, a number times 0 gives you 0, so 0 times 0 would give you 0. And that is a one solution situation where only 0 can give you a 0 outcome. And then two solutions would be like if I had n squared is equal to 4, right? There's two ways I can get 4. I can do negative 2 squared equals 4. Let me make that square a little better. Equals 4, but I could also do positive 2 equals 4. And that's where you have a two solution situation where both 2 and negative 2 can give you 4 here. Okay? All right, so that's what we're looking for. That's what we're doing when we're doing these example problems. We're looking for one of these three situations. Either a square of a number giving us a negative number, which means there's no solution, because according to this course, and you'll learn more about this later, that you can take a negative square root, but we get into this whole imaginary numbers thing. But for right now, we're just going to assume that if you have a squared number and it gives you a negative answer, like g squared equals negative 9, that actually is a no solution situation. All right. Later on in math, you're going to learn about I, which equals the square root of negative 1, but we're not talking about that right now. Just know for right now it means no solution. And then if you have anything to the square equaling 0, that's one solution. And if you have anything that could give you a possibility of a positive or negative answer, you're going to have a two solution situation. So let's go ahead and do an example problem. Let's go back here a second. Too far. Let me erase some stuff. There we go. So then if I go like that, there we go. So notice how none of the examples have bx. Just know that then the axis of symmetry for this particular lesson will be the y-axis. Okay? So let's go ahead and do the first example, 2x squared plus 4. Well, if I minus 4 on both sides, because I'm trying to get x by itself, I'm trying to solve for x. That's why we're dealing with quadratic equations. We're solving for one variable here, x. So if I minus 4 on both sides, they're going to cancel out, they're gone, and I have 2x squared equals negative 4, divide by 2, and then I have divide by 2 on both sides, and I have x squared equals negative 2. Well, nothing times itself will give me a negative number. Therefore, there's no solution. X squared cannot equal a negative number for this course. Therefore, there is no x-intercept for this parabola, and that means that the parabola will never hit the x-axis. It's never going to go through there. Okay. So second equation, we have x squared minus 25 equals 0. Well, I'm going to add 25 on both sides. Those are going to cancel out right there. And I'm going to get x squared equals 25. Well, there is two solutions for this because there's two ways that I can get 25 when I square a number. So if I square 5 times 5 is 25, but I could also square negative 5, which is why we talked about in the last lesson that if you take the square root of a number, a positive number, it's going to give you two possible outcomes. 5 times 5 is 25, but negative 5 times negative 5 is also 25. Therefore, x can be two possible things. It can be negative 5 and it can be positive 5, hence why we write it like that. Okay, so the two possible solutions for this, the 2 points where this line is going to hit the x-axis is at 5, 0 and negative 5, 0. And those are the two x-intercepts, which is why this has two solutions, 5 and negative 5. Cool? Okay, good. Moving on. All right, next problem. And you'll notice that negative 16 cropped up because I'm just going to quickly go through this. You might figure it out just looking at it. So if I plus 16 on both sides, that's going to cancel out, and I'm going to get x squared equals 0. Well, the only thing times itself that can give me 0 is 0. So x has to equal 0, and it's the one solution because it's the one place where the parabola hits the y or the x-intercept at 0, 0. And that's also probably going to be my vertex, and I know it's my vertex because I also don't have a bx. Therefore, my axis of symmetry is going to be the y-axis, so therefore when y equals 0, I'm going to get my vertex, which in this case is also 0, 0. It all works out. You guys should be able to prove it by graphing it as well as doing the math. Okay, so next problem, we have 3n squared plus 12 equals 12. So if I minus 12 on both sides, divide by 3, Take the square root, it's also one solution, 0, 0. All right, last problem. We have 2g squared plus 32 equals 0. So I'm going to minus 32 on both sides, divide by 2 on both sides, and I get g squared equals negative 16. Again, nothing times itself will give me a negative answer. So doing this isn't going to work. All right, it's not the fact that I can't take the square root of a negative 6. It's 16, because again, there's that whole I thing. But nothing times itself will give me a negative solution. Therefore, there's no solution, and the vertex of this parabola is not ever going to be on the x-axis, nor will any other part of the parabola be on the x-axis. So there's no solution for the fact that we are looking for the x-axis. All right, or where the parabola hits the x-axis. All right, so no x-intercept, no solution. All right, so you can solve real-world problems by finding square roots. In many cases, the negative solution of a quadratic equation will not be a reasonable solution to the original problem. So if they're asking me, in this case, for the radius of the pond, saying the radius is negative 3 feet makes no sense. I can't have a negative 3-foot radius duck pond. Not going to work. So even though I might end up having two solutions to this problem, only one of them is going to make sense, the positive one. Okay, so let's go ahead and look through this. A city is planning a circular duck pond for a new park. The depth of the pond will be 3 feet and the volume will be 180 feet cubed. Find the radius of the pond to the nearest tenth of a foot. All right, so we've got a formula here, and it's the volume equals pi times r squared h, where I'm going to use 3.14 for pi, r for radius, and h for height. So if you can imagine, we've got this duck pond, and I'm going to draw a picture of it, and it kind of looks kind of like an above-ground pool. All right, where r is the radius, and the volume is the whole thing, and the height is 3 feet. Okay, so there you go. You can even kind of visualize it as a glorified tin can, I guess, just big enough to fit ducks and whatnot, and it's 3 feet high, and it can hold 1,800 feet of cubic water, which is, pretty big. Quite a few ducks could probably enjoy this pond. Anyway, let's go ahead and figure out what the radius of this hypothetical pond is. So we know that the volume is equal to pi r squared times h, times the height. So I'm going to replace the values with what I know. Well, actually, I could probably go ahead and replace this with 3.14, because that's what I end up using. Now again, radius doesn't equal 3.14, it's approximately 3.14, and it's good enough for this particular question because they want us to round to the nearest tenth of a foot anyway. And even though they say tenth of a foot, I think I'm going to round to the whole foot just to be like, cheeky. All right, so let's go ahead and do some math. All right, so I need to pull away the pi, which I said I was going to use 3.14. Just imagine that pi is a 3.14 right now. I'm going to move the 3.14 and the 3 feet height away from my r squared so I can get it by itself. I'm going to divide them on both sides, which means they're going to cancel out on the right, and I'm going to divide by them on the left. So I'm going to get 1,800 feet cubed over 3 feet times pi, or 3.14. 3.14, Miss DH. There we go. Okay, so just remember that if you have the same thing on the top and the bottom, you can cancel out what you have the same of. Since I have foot cubed on the top and foot to the first on the bottom, I can actually cancel them out and get foot squared on the top, and the foot down here actually cancels out. No, that's a little too far. But yes, it cancels out. Let me just cancel it out. Gone. Anyway, so okay. So it cancels out. And I'm going to then therefore, go ahead and take the square root of r squared, which is going to cancel out the square. Actually, if I go back, you can see me type it out. There you go. It's going to cancel out the r squared, and I'm going to take the square root of everything on the left, and I'm going to get r is approximately, because again, I'm rounding anyway, and I'm using 3.14, so it's not exact as it is. So r is approximately the square root of 1,800 feet squared over 3 times 3.14. So if I go ahead and do that and do the math, I've got r is approximately the square root of 1,800 feet squared. But again, I'm doing the square root, so actually even this one right here, that square right there, it cancels out, leaving me just feet, which is good because I want feet for my radius anyway. And then 3 times 3.14 is 9.942. I go ahead and divide, and I'm going to get, and then take the square root. I believe that 1,800 divided by 9.42 is around 191, which then when you take the square root gives you roughly 13.8. But again, it's plus or minus because, again, everything in here was positive, so that means that it is a possible solution. The only thing is this whole negative business. It doesn't matter because my pond is in no way going to be negative 13.8 feet. There's a good chance it's positive 13.8 feet, but it's not ever going to be negative 13.8 feet. So if I were to round to the nearest tenth of a foot, that would be my solution. But, you know, let's just go ahead and round it up. So my radius of my pond is approximately 14 feet. All right, I'm done, guys. Bye.